So today we'll discuss about the different application of operational amplifier. I have already uploaded the material, but in that the derivations are not there. I'm doing the derivation, so along with me, you also do the derivation in your copy. So yesterday we have discussed about virtual ground concept. So if you see, just revise that one. So this is the op-amp. Okay, so V naught equals to A into V1 minus V2. Okay, so A is equals to V naught by V1 minus V2. Ideally A is infinite, or practically it is very high, so the denominator should be 0. So that means V1 minus V2 should be 0 or nearly equals to 0. So that implies you can say V1 equals to V2. Okay, now if one terminal V1 is grounded, I'll ground the V1. If V1 is 0, that implies V2 will also act as 0. Even if V2 is not grounded here, you can mark here, I have not grounded the V2 terminal, but it will act as ground. So this is called as virtual ground. Okay, if it is not grounded, then both the terminal voltage will be remain same. So this concept will use along with KCL to see all the applications. So first we will take this is my op-amp where the inverting terminal is connected with one resistance. Let us take Ri, and feedback resistance which is connected from output to input as Rf. V naught is the output and Vi is the input. Okay, now let us take, this is my point A, and potential at this point is Va. Okay, and the non-inverting terminal is grounded, means the voltage here is 0 volt. So just now we have discussed, according to virtual ground concept, if one terminal voltage is 0, other terminal voltage will also be 0. So from that concept, Va equals to 0 volt. Okay, now if Va equals to 0, then we'll find how much current is flowing across this terminal, because there is a potential difference. At the input we are giving Vi, and at Va the voltage is 0, so there must be some current will flow, and let us that current I'll take as I1. And when this current is flowing, it has two options. It can move into the op-amp like this or like this. Okay, uh, during the discussion of characteristic, I have told you the input impedance of the op-amp is very high for practical case, and it is infinite for ideal case. So that's why when current is flowing, it will not enter into the op-amp due to this high impedance or infinite resistance. So obviously it will go through RF, because we know the current is always flowing in the lower resistance path. So here, if you look at the op-amp, I'll see this resistance is very high or infinite, so current will move in the feedback path. Okay, so let us take that current is I2. So applying KCL at point A, so I have taken as A, what will get? I1 equals to I2, entering current should be equals to outgoing current. So what is I1? I will find the I1, the potential difference between the 2 point and the resistance. So I can find I1 as Vi minus Va divided by Ri, which is equals to, what is I2? Va minus V0 by Rf. What is Va? That is 0. So that implies Vi by Ri equals to minus V0 by Rf. Now, if I want to find V0, then just take Rf one side and negative terminal or negative sign one side. What I'll get? Rf by Ri into Vi. Okay, so output voltage we have found out in terms of input voltage with one factor minus Rf by Ri. Suppose I will take Rf as 20 kilo ohm and Ri as 10 kilo ohm, then what I'll get? V0 is 2 times of input voltage with negative sign. So that negative sign indicates phase difference. Suppose I am giving the input voltage like this, 2 volt peak to peak, then output voltage will be like this, which will be 4 volt. Okay, so 2 times of the input voltage with inverted. So that's why this is called as inverting amplifier using op-amp. Understood? So this concept will be repeated in all the circuit. Okay, so what is the basic thing? What is virtual ground? If it is not grounded, then V1, both the terminal voltage should be same for op-amp, and we have to apply KCL. If you know these two concepts, then all the circuit what we will derive, you can easily understand. Any doubt from this circuit derivation? In the PPT only circuit diagram is there, the derivation is not there. Okay, so you write down all these things, and maybe somewhere you will find RF or RI or RF or RIN. Instead of VI, it should be V in. So anything can be, that is only the assumption, whatever you can take. Is it understood all? अरे समझ में आया कि नहीं? रिप्लाई करो.
Yes, sir.
Next we'll go for next circuit. It is same as the previous one, but only one difference I'll show you.
Excuse me, sir.
Yes.
Can you go to the previous slide? Thank you, sir.
So this is output, and this is RF, this is RI, and what I'll do, earlier I have given the input voltage in the inverting terminal or this negative terminal, pin number 2. Now what I'll do, I'll ground this pin number 2 and give the input voltage in the non-inverting terminal. Okay, so if I'm giving the voltage Vi in the non-inverting terminal, then the point A or the second terminal voltage will also remain same. So Va equals to Vi. Okay, because we have seen here, if it is grounded, then we are getting V2 equals 0. If it is not grounded, V1 equals to V2. Okay, so Here I have not grounded the inverting non-inverting terminal, so whatever voltage I'll give, the same voltage will appear at the inverting terminal. Okay, then same way we can find, let us assume current I1 is flowing and no current is flowing into the op-amp, so I2 current is flowing across the feedback loop. So apply KCL at point A, what I'll get, I1 equals to I2. What is I1? 0 minus VA divided by Ri equals to VA minus V0 by Rf. What is VA? VA equals to VI. I have already taken, so that implies 0 minus VI by Ri equals to VI minus V0 by Rf. It implies minus Vi by Ri equals to Vi by Rf minus V0 by Rf. I'll take Vi one side, so minus Vi by Ri minus Vi by Rf equals to minus V0 by Rf. Then you take common minus, and left hand side, right hand side, it will cancel, and I am taking Vi as common, 1 by Ri plus 1 by Rf equals to V0 by Rf. What I want V0, so I'll multiply Rf in the left hand side, so that in the right hand side Rf will cancel. So if you multiply Rf in the first term, I'll get Rf by Ri, then second term it is 1, so 1 plus Rf by Ri into Vi. So this is your output voltage. Suppose I am giving here 2 volt as input voltage Vi, and Rf is 20 kilo ohm, Ri is 10 kilo ohm. Tell me what is the answer, or how much voltage I'll get at the output. Rf 20, Ri 10, Vi is 2.
Sir,
So what is your output voltage?
sir 4.
अच्छे से देखो.
Sorry, sir, 6.
6 volt. Okay. Because 1 plus Rf by Ri, so it will be 6 volt. So this is called as non-inverting amplifier. Using op-amp. I think you have done these things in the lab. Now, sometime what is required, the output and input voltage should be same. Suppose I'll have a circuit where whatever input I am giving, the same output will get. Those type of circuits are called as buffer, or in precise it is unit gain buffer. Because if you find, suppose output equals to input, so what is the gain? Gain means, or AV means output by input, so gain is 1. Okay, so that's why this is called as unit gain buffer. If gain is 1, why it is required? Actually it is required to match the impedance. Suppose I'll have 2 circuit, and in between that I want to transfer the power. So in some cases, like RC coupled amplifier we have discussed, here the coupling thing is this buffer. Okay, so impedance matching purpose we are using that one, where voltage should remain same, but input impedance, output impedance should be matched with other circuit. That means circuit 1 and circuit 2. In between that intermediate stage, we'll use that one. So if you want to design this circuit, we'll use the previous concept. here what we have got here, V naught equals to Rf by Ri plus 1 into Vi, or 1 plus Rf by Ri. So if I make this term as 1, then I'll get V naught by Vi as 1, or V naught equals to Vi. So for that we have to make this is 0. So the feedback resistance, if I'll take as 0, then I'll get unit gain buffer. So this is the circuit where you'll get unit gain. Okay, see here, this is Vi, right? So what we are getting here, V naught equals to, for non-inverting op-amp, 1 plus Rf by Ri into Vi. Here Rf is 0, so 0 by something, that is 0, 0 plus 1, 1, so V naught equals to Vi. Okay, so here instead of resistance Rf, I have sorted it, and R1 I am not using here. Clear? Is it clear?
Yes, sir.
Next, we'll proceed for another circuit. The application of inverting amplifier. You see, instead of single resistance, I am taking 3 resistance here: R1, R2, R3, V1, V2, V3. This is grounded, and from here to here I am connecting one feedback. So V naught, RF, negative, positive. So this is the circuit. Let us see what is my output. So here the non-inverting terminal is grounded, so here we'll get 0 volt. Let us take this point is same as this point, which is point A, and can you tell me what is the potential at VA? What is the potential at VA? One terminal is grounded means other terminal will also act as ground, so this is also 0. Then some current will flow here. Let us assume this is I1, this is I2, this is I3. Op-amp into the op-amp current will not flow, so it will bypass through RF. Let us say this is I. Okay, so apply KCL at point A. So what I'll get, I1 total input current should be equal to total output current. So I1 plus I2 plus I3 equals to I. What is I1? V1 minus VA. VA is 0. So V1 minus R1 plus V2 minus 0 by R2 plus V3 minus 0 by R3 equals to 0 minus V naught by RF. That implies V1 by R1 plus V2 by R2 plus V3 by R3 equals to minus V naught by RF. Right. Now if R1 equals to R2 equals to R3 equals to RF, if all the resistance are equal, then what will get? All the resistance will cancel each other. Then V naught I can write minus of V1 plus V2 plus V3. Okay. So what is happening here? The input voltage are added and it is inverted. Okay. So these are called as summing circuits. summing amplifier. Suppose I will give here minus 4 volt, 2 volt and 3 volt, and all resistance are equal, then what is my output voltage? Minus of minus 4 plus 2 plus 3. So how much? This is 5 minus 4, 1 minus 1 volt. If all the resistance are equal. If resistance are not equal, then you have to find it this voltage, then multiply with RF, then that is your output voltage. Okay. Are you getting my point?
Yes, sir.
I have given one question in assignment 2. I have uploaded today, so you can check it and solve that problem related to this one. Next, we'll see another circuit. Have all of you written, no? Previous one?
Yes.
Now see, this is another circuit. So output voltage V0 is RF, or instead of RF you take some other value. Okay, let us take this is 1, this is 2, this is 3, this is 4, and I'm giving here V1, giving here V2. Okay, so in the previous 3 or 4 circuits, we are directly giving one terminal input voltage, or we are grounding it. But here we are not giving any ground here. In both the terminal, we are giving some voltage, and that is not equal to V1, V2, because op-amp terminal is means what? This is one terminal and this is another terminal, and I am giving here V1 means it is not same as the potential. Suppose I am writing here this is point A and VA is the voltage, and this is point B or VB as the voltage. So V1 is not equal to VA because resistance is there. Suppose I am giving V1 as 5 volt and some voltage will be drop across R1, that will be not equals to VA. Similarly, V2 voltage I am giving here, so that is across R3, some drop will be there, so that is not equal to VB. So how to find V and VB? We know voltage division rule. You can go for that. Otherwise, you can directly use this VA and VB value, and you can calculate the output voltage in terms of input voltage. So let us see how I am finding. So if VA and VB are the voltage at this two terminal of the op-amp, then we know both the voltage will be remain same. So VA equals to VB. If you are giving V1, V2 directly to the op-amp, then both the voltage are remain same. So here also we are giving VA and VB, so voltage will be remain same. Okay. According to virtual ground concept, it is not grounded, but voltage is given, so same voltage will appear at both the terminal. Now due to that, some current will flow. Let us take this is I1 current, and this is I2 current, this is I3 current, and this is I4 current. So applying KCL at point A, what will get? I1 equals to I2, because current will not enter into the op-amp, obviously it will go through R2 to ground. So what is I1? V1 minus VA divided by R1, which is equals to VA minus 0 by R2. Now if both the resistance are same, R1 equals to R2, then what will get? V1 minus VA equals to VA, that implies V1 equals to VA, that implies VA equals to VI by 2. Okay. Next, let us see at point B what is happening. So apply KCL at point B. So I3 equals to I4. What is I3? V2 minus VB divided by
R3.
I3 equals to VB minus V0
V
by
R4.
R4. VA equals to VB, so I can replace there. So V2 minus VA divided by R3 equals to VA minus V0 by R4, because VA equals to VB. Now if I'll take all the resistance are same, then what will get? V2 minus VA equals to VA minus V0. Take one side VA, V2 minus 2VA equals to minus V0. Then replace VA as VI by 2. So V2 minus 2 into VI by 2. So 2 to cancel equals to minus V0. So what I'll get? V0 equals to V2 minus V1. Here negative. So multiply negative. So I'll get VI minus or V1. This is V1, na? V1 minus V2.
Yes, sir. V1.
V1 minus V2. So what is happening here? The two voltages whatever we have given here, that is subtracted. Okay. Suppose I am giving V1 as 5 volt and V2 as 1 volt. So output will be 5 minus 1, that is 4 volt. So this is called as subtractor or differential amplifier. Using op-amp. Okay, output V0 equals to V1 minus V2. So we have seen inverting, non-inverting, unit gain buffer, summing, and subtractor or differential amplifier. Okay. Next we'll see another two type of circuit which will integrate and differentiate the input signal. Is it completed?
Yes, sir.
Next I am taking one op-amp and putting one capacitor instead of resistor and one resistor here, and this is grounded, minus, plus, Vi, capacitor, resistor, V0. Okay, same circuit, but instead of resistor at the input side I am taking capacitor. So let us see what is happening here. So you can see this is grounded, means this is 0 volt. So if I take this is point A, so potential at point A will be 0 due to virtual ground. Now some current will flow here. Let us take I1 and here I2. So apply KCL at point A. So I1 equals to I2. What is I1? We know Q equals to C into V. Okay, in 12th standard you have studied. So if you differentiate dq by dt is equals to, you will get C dV by dt. What is dq by dt? That is current. So C dV by dt. That means if capacitor is there, then how much current is flowing across that we can find by C dV by dt. So I1 is flowing through the capacitor. So what I'll get? C dV. dV means what? The differential voltage between these two terminal. So dVi minus 0 by dt equals to the resistance current or current through the resistor is Va minus V0 by R. So Va minus V0 by R. So C dVi by dt equals to VA equals to 0, so minus V naught by R. That implies V naught equals to minus here in denominator, so it will go to upside minus RC dVE or VI by dt. Okay, so you see the output voltage is differentiated d by dt with VI. Okay, input voltage is differentiated with a factor minus 1 by RC. So this minus 1 by RC is the amplification factor. So this circuit is amplifying the signal as well as differentiate the signal. Okay, so this is called as a differentiator. Okay, understood?
Yes, sir.
Now other circuit integrator, you know, integrator and differentiator are reciprocal to each other. Okay, so that is you can do by very simple change in the circuit. We'll just interchange the capacitor and resistance position. So here I'll keep the resistor, here I'll keep the capacitor. This is your output voltage, this is grounded, VI R C minus plus. This is 0 volt. Let us take this is VA point A. Okay, so VA equals to 0 due to virtual ground. Okay, so after that we apply KCL at point A. So what I'll get, let us take this is I1, this is I2. So I1 equals to I2. What is I1? VI minus VA divided by R, which is equals to here C dV by dt. So C dV by dt means d VA minus V naught. So for that I'll get VA 0. So I'll get minus d V naught by dt. Okay, so that implies VI by R equals to C minus C dV naught by dt. What is my requirement? My requirement is to find out V naught. So you take capacitor and negative sign to the left hand side, so that I'll get minus 1 by RC into VI. Okay, here in the left side I'll get dV naught by dt. So I'll integrate both sides. So if I integrate, left side dy dt will cancel, and right side I'll get Vi with respect to dt. So limit will be 0 to t. So I'll get this one plus some constant. So output voltage is integrated here. So whatever input voltage will give, that will be integrated with a factor minus 1 by RC. Okay, so that's why it is called as integrator. Integrator circuit. So till now 7 circuit we have seen: inverting, non-inverting, unit gain buffer, summing, differential, integrator, differentiator. Okay, differential and differentiator are both different thing. Differential means difference between two signal, or subtractor. Differentiator means d by dt. We are doing differentiation of the input signal. So whatever it is coming in the exam, you should understand accordingly. You have to write. Otherwise, differentiator will ask, and if you write differential, then mark will be 0. Similarly, the reverse one. Okay, understood? Now I'll give one question. Let us see how many of you are able to do. Okay, find the value here. 3 op-amps or circuit are cascaded, or output of a circuit is given to the second circuit input, like that it is connected. Tell me what is the answer. Let's see how many of you will do. बताओ किसका हुआ?
Sir, is it 8 volt?
तो निकालना पड़ेगा, मुझे पता नहीं है, ऐसे ही दे दिया. See, how you will solve those who have not solved. You have to divide this is in 3 part. So this is part 1, this is part 2, this is part 3. So for first one is inverting amplifier. So what is the formula for inverting amplifier? Minus Rf by Ri into Vi. So here 10k divided by 5k into 2 with negative sign. So how much will get? Minus 4 volt. Have you got this one?
Yes, sir. Yes, sir. Why -1?
Okay. So here input is, for the second stage, the input is minus 4 volt. So for second stage it is non-inverting amplifier. So 1 plus Rf by Ri. So 20 by 10 into Vi. Right. So 2 plus 3 into minus 4. That is how much? Have you got this one? So I'm taking this is V01, this is V02, and that is V0. So V01, V02 have found out. Okay. So input for this one is minus 12 volt. Right. So this is a summing amplifier. V0 equals to addition of all these input voltage, because resistance are equal. I have not given unequal resistance. So minus of 5 minus 2 minus 12 plus 1. Right. So how much you are getting? 12 minus 2 14, 14 से 6 गया, so 8. See, तुम्हारा कितना आया था? कौन बोल रहा था?
Sir, 8.
8 volts. Okay. So like that you can solve it. सबका आ गया?
Yes, sir.
You can do any circuit will be given. You can do like this. Even integrated differentiator can be also cascaded to that one. Okay. If integrated differentiator will be cascaded, then also you can find the same thing. The same process will be followed. So that's it today. We have completed the optional amplifier. Just wait for 1 minute. I'll take the attendance. So we are towards the end of the syllabus. Next class we will discuss the power amplifier. Next class means again Monday. Monday or the Saturday. Which day's class is there? This Saturday?
So Tuesday.
Tuesday timetable.
Tuesday timetable. Okay.
Sir, so that you have given assignment on that research, sir, that
Assignment on?
topic you have given, no?
Mm-hmm.
Like we have to what to do, we have to like my topic is photodiode, so basically I have to take the help of photodiode and make one what activity or assignment what to do. I didn't understand it.
No. What is photodiode? You have to explain. Suppose we are studying operational amplifier, means what we have studied. What is the symbol? Right.
Yes, sir. Yes,
What
sir.
is the operation, characteristic, application?
Yes, sir.
So like that, photodiode. What is photodiode? You need to understand that one. What is photodiode, and how it is different from diode? Why it is called as photodiode? If it's having characteristic, you have to draw the characteristic. Application, you have to draw. Okay, you have to write the applications. That's it. Like suppose I am teaching you some topic, means from starting to ending, that means from concept to application we are studying. So you think that you are studying that topic and you are giving a report, that means anyone will study that one, means they can have one idea about the photodiode. In that way you can think, and that is up to 3 to 4 pages or maximum 5 pages, not more than that.
Basically we have to write all the things about the photodiode, means the topic is for working principle, how it is it, how it is circuit diagram, basically all that things we have to write.
And application.
Okay, sir.
अभी कौन कौन ज्वाइन किए हैं? 78 स्टूडेंट था, मैं अटेंडेंस ले चुका हूं, ठीक है. अभी 81 है, मतलब 3 स्टूडेंट्स हैव ज्वाइंड फॉर अटेंडेंस. ऑलरेडी अटेंडेंस इज ओवर.
Sir, one more doubt, sir. Like,
Yes.
sir, photodiode application is used in smoke signal, sir. Like smoke